Okay, so what we start today is probably something super familiar. This unit C, this third one that we're going to do this semester, tends to be one that students come into this class fairly familiar with. So this gives you a great opportunity to get back onto firmer ground maybe and to reset, maybe get a great grade on this next test. So hopefully all this stuff is familiar, and what is not, you will take every opportunity to ask a question. So what we're going to talk about for most of this unit is something called factoring. The reason we spend a whole unit on it is when you get to college algebra, if then you go beyond that to pre-calculus, factoring is just an implied skill. It's something that we assume you know. When you take college algebra, if you have me in the spring, I'm not going to talk about factoring. I'm just going to assume that you know how to use it in the situations that it comes up. So for that reason, it's fairly important for you to learn how to do this fairly well and recognize how to factor. So we're gonna go through this. So what we're gonna do today is we are going to just basically see what the premise of all factoring is. And basically all factoring is we're unmultiplying something. So today what we're gonna do is we're gonna look at unmultiplying or factoring when I can see that there is a common factor to my terms. And the thing to keep in mind is whenever we're factoring, we want to factor everything completely. We want to make sure that what we have left cannot be factored anymore. That's how I know I'm to the end result. Okay, and that'll come into play in a couple problems. And if you have any questions about why maybe you've factored out something different and it's not completely factored, let's talk about that. So here's my first example. We're going to factor 9x plus 18. And so what we're going to do for basically this whole front page and most of the second page is we're going to ask ourselves this question. Between these two terms, I've got the term 9x, I've got the term 18. Between those two terms, is there a factor that they have in common? What would that be? Not 18. 18 is not a factor of this. Remember, what you're thinking of is the word multiple. Multiple means I'm multiplying to get larger numbers. And you would be right if I was asking what the common multiple is. 9 times 2 is 18, and 18 times 1 is 18. You're 100% right. Factors are the components of numbers. Okay, so is there a factor that I can use to get 9 and a factor that I can use to get 18? Okay, now 3 would be one answer. We're going to talk about that in just a minute. So I'm going to write a 3 right there. But there's a bigger factor that I could do this all in one step. 9. Okay, so I'm going to do this problem both ways because what you've just illustrated is something that can happen. And it talks to this idea of factoring something completely. So I'm going to do this first, seeing 9. 9 is in common to both 9 times 1, and 18, 9 times 2. So I'm going to factor out the 9. And what I'm just doing here is I am basically undistributing or dividing, however you want to think about it. Here's how my brain works on this. I factor out the 9, and this is what I ask myself. 9x divided by 9 leaves me what? X. 18 divided by 9 leaves me 2, positive 2, sure. Another way to think about that might work for you. Maybe you don't like the division step there. You might say, okay, what in this space times x gives me 9x? Well, that's the x. And then what in this space times 9 gives me 18, and that would be 2. Okay, just different ways of looking at the same thing. If you have another way of talking yourself through the problem, that's good. But this is the final completely factored expression. I've got two things multiplied together that would give me 9x plus 18. Now, I know some of you are thinking, oh, hey, I would have said 3. Would that have been wrong? Well, not completely. So if you had said 3, here's what would have happened. You would have said this, okay? 9x divided by 3 leaves me what? 3x, yes. And then 18 divided by 3 leaves me 6. Is there anything left in common here between these two terms? Yeah, there's another 3. Now, sometimes the numbers work like that. Sometimes you're going to see part of it. Maybe the numbers are a little larger. You're going to see part of it, and you have to do this in 2 steps. There's nothing wrong doing that. Just make sure you factor completely. So what we'll do now, I'm just going to write another equal sign, is I've got this 3 that I've already factored out. And now you just told me that there's another 3 in common to these two. So I'm going to take that out. And now 3x divided by 3 leaves me x. 6 divided by 3 leaves me 2. And then the last thing I'll do, and of course, as you get better at factoring, you can consolidate these steps. Okay, you don't have to write all these things down if some of this is clear to you. 3 times 3 is 9. So notice either way, I get the same 2 factors. I have the factor 9, and then I have the factor x plus 2 when I factor this completely. All right, now we're just going to practice. So exercise 1, straight to the right. It says 8x minus 12. Please factor out the common factor and also make sure when you're done it's factored completely. All right, between 8x and 12, what factor do they both have in common as a component of both of those? 4, yeah. Now, if you said 2, because you saw both of those are even, that is a great first step. Okay, so please don't hear me say that you're wrong or feel defeated. It just means you've got to do a second step because both numbers you get will still be even. So you factor out another 2. I'm just going to do this in the 1-step way, though. I'm going to factor out the 4 that you told me. And now 8x divided by 4, what's left for my first term? 2x. And then negative 12 divided by 4, what's left for the second term? Negative 3. Is there anything in common to 2x and 3? No. Nope. They're mathematically, that's called co-prime numbers. You don't need to know that at all. That's just me trying to be fancy with you. All right, exercise 2 right below. Same sort of thing. 6y plus 24. Factor out the common factor. Right, so 6y plus 24. What factor do both 6y and 24 have in common? Yep, 6. Great job. Again, if you'd said 3 or you said 2, that is a great first step. You're just going to have to do another step. 6y divided by 6 leaves me y. 24 divided by 6 leaves me plus 4. We doing good so far? Okay, well, let's keep going. The next exercise, right to the right, the whole purpose of the next exercise is just to show you we can do the same thing if there's 3 terms as if there were 2. Okay, so go ahead and factor exercise 3. What is in common to all 3 of those terms? Don't shout it out. We'll talk about it in a minute. So 28x squared, 21x, and 35. What factor do those three numbers have in common? 7, sure. So I'm going to say this is going to be equal to 7. I'm going to put a nice large parenthesis. And the same question I've been asking. 28x squared divided by 7 leaves me 4x squared. Then the 21x divided by 7 leaves me plus 3x. And then the 35 divided by 7 leaves me plus 5. There's nothing in common in those three terms. I have factored completely. Still doing okay? All right, one more, and then we're going to talk about variables. Okay, so exercise 4, right below the exercise 2, same thing. So between 15x cubed and 25x and 5, what is the factor they have in common? 5. Now, I do have an important thing to mention to you about this example, the reason for it, and it has to do with that third term. So when we get there, if you have any question, we need to just make sure we nail that down because it's going to happen more than once. 15x cubed divided by 5 leaves 3x cubed. 25 divided by 5 leaves me 5x. And now here's the last term. What happens when I factor the 5 from the last term? What's 5 divided by 5? 1. That term is important. Don't just say, oh, there's nothing left and leave it blank, okay? Because then you'll change the number of terms. There are 1, 2, 3 terms. So I have to put a +1 right there. So if you left that off, I understand. It's a common mistake. That's why I'm making a big production of it. Okay, make sure you include that 1 because remember, when I remultiply, I should get what I started with. And if you don't have a 1 there, then you would only have the first term and the second term, but not the third. Okay, so keep that in mind. Okay, I think there's another problem or two as we go through today that'll happen. So you'll get the chance to make sure that you note that detail. Okay, example 2. Just to the right, this is my next example, because in all the problems we've done so far, we've just been looking at the coefficients, the numbers. Now we're going to talk about variables. So what do I factor out? So look at this. I've got 5x to the 4th, and I've got 4x squared. Now the 5 and the 4, they don't have anything in common. Okay, 5 is odd, 4 is even, so nothing going on there. But the x's, this first term, how many x's does this first term have? 4. How many x's does the second term have? 2. So if I was going to take the same number from both of them, how many can I take from both of them? 2. Yes. Okay. So in general, here is the principle. Notice the lowest power. When you're looking at factoring variables with exponents, you always just look at what is the lowest power. So I can factor out 2x's, meaning x squared. So I'm going to write an x squared out in front. And here's my parentheses. I've got 5x to the 4th. I take 2 of the x's out. That leaves what as my first term? Yep, perfect, 5x squared. You can also remember that in the last unit, last week, we talked about what you do when you divide things. We subtract the exponents. So 4 minus 2 would leave me 2. That's another way to think about it if you prefer. And then the second term, I've got 4x squared. I took the 2 x's out. What's left? Just the 4, yes. And there we go. Nothing in common. Exercise 5 is very similar to what we just did. I've just changed the numbers a little bit, so give that one a try, please. All right, so I've got 7y to the 6th. I've got 5y to the 3rd. Again, the coefficients, the 7 and the 5, there's nothing in common. How many y's can I factor out of that? 3. Yeah, they both have 3 that they can give up if I'm taking the same. So I'm going to factor out that y to the 3rd. And so 7y to the 6th, when I take 3 of the y's, or if I'm subtracting the exponent, 6 minus 3 leaves me 7y to the 3rd. And then minus 5y to the 3rd, when I factor out the y to the 3rd, just leaves me 5. So far, are we so good? All right, now we're going to combine both of those two things. Okay, so the first few problems, we talked about coefficients. The second couple problems, we did the lowest exponent. Now the next few problems that we're going to do, I'm going to do one, and then you've got 3 or 4 you're going to do. We're going to do both. Okay, because that's the kind of the more common thing to happen. So look at my example 3 right here. I'm going to do this one with you. I've got 16y to the 5th, 4y to the 4th, 8y squared. So let's just look at one part at a time. First, the coefficients. What is common among 16, 4, and 8? 4, yeah. Okay, good correction. So we got the 4. And then y to the 5th, y to the 4, y to the 2nd. How many y's can I take out of all those? Y to the 2nd, yeah, 2. Always the smallest exponent, every time, every day. Are you tracking with me? Do we do anything confounding there? All right, so here's my parentheses, and now I just do the same thing. I just think about these things separately. The more of these you do, the quicker you'll be able to do them, I promise. So 16 divided by 4 leaves 4. And then y to the 5th, I took out 2 of the y's. That leaves me y to the 3rd. Negative 4 divided by 4 leaves negative 1, or just a negative. And then y to the 4th divided by y squared, or when I take out 2 of the y's, this leaves me y squared. Then 8 divided by 4 is 2. And then I started with y squared. I took the y squared out, so there's no more y's left in that last term. Exercise 6. We're just going to do some different varieties. Exercise 6 has two variables, but I think you can do it. Give it a try. Yes. All right, so let's give this a try. Now, if you didn't know what to do with the two variables here, it's okay. You've got a couple more examples in a minute that you'll get to practice on. So just learn from your mistakes here or ask whatever questions. So both of these terms have m's and n's to them. So let's just take it one variable at a time. My m's, I have 2 m's in the first term. I have 6 m's in the second term. So how many can I factor out? 2, always the lowest power, every time, every day. So m squared, I can factor that out. And then I've got 4 n's in the first term. I've got 3 n's in the second term. How many n's can I factor out? 3. Yep. So if you didn't see to do that, that's okay. Hey, that's why we do all these varieties of examples, is so that you see exercise 8 and 9 involve 2 variables. So you're going to get a chance to redeem yourselves there. But in the meantime, my first term started with 2 m's and 4 n's. I took out 2 m's and 3 n's. What's left? Just one n. Yep. No m's are left. You're right. I took both of them out. And then I started with 4 n's. I took 3 of them out because I always take the smallest exponent. Plus, my second term started with 6 m's and 3 n's. I took out 2 m's and 3 n's. What's left there? 4 m's. M to the 4th. Great. There we go. Done. There's nothing else in common to those two. So that problem is completed. All right. So exercise 7 involves variables and coefficients, just like example 3. So give that one a try. 24p squared minus 9p cubed plus 6p to the 4th. So first off, the 24, the 9, and the 6. What do the 24, the 9, and the 6 all have in common? 3. Yep, that's great. And then p squared, p to the 3rd, p to the 4th. How many p's can I factor out? 2 of them, p squared, for sure. Excellent. So my first term, 24 divided by 3 is 8. I started with 2 p's. I took out 2 p's. There's no more p's left in the first term. Second term, minus 9 divided by 3 is 3. Started out with 3 p's. I factored out 2 of them, so that leaves me 1. And then plus 6 divided by 3 is 2. Started with 4, factored out 2, leaves me 2. Anybody got a question? You doing okay? Please ask. I want this third test to be an amazing grade for all of you, please. Okay, so that's why I'm here. Otherwise, I just show you a video and I'd sit here doing nothing. Okay, so I'm here for questions. I want to help you. Please take advantage of that. Okay, exercise 8. Okay, we got coefficients and 2 variables this time. It's just a little bit more fun. Bless you. All right, there's a lot going on in this problem. So let's see what happens here. So coefficients, I've got a 9, a 3, and a 6. What factors in common to all 3 of those? Okay, 3. Then I've got x cubed, x squared, x squared. How many x's can I factor out? Yep, 2 of them, x squared, and then y squared, y squared, y third. So the y's, y squared. Great. That's the first challenge. Can you identify what to factor out? And the best thing to do is you're just learning and maybe trying to get some confidence is just go one thing at a time. Look at the coefficients first, then look at the x's, and then if there's another variable, we look at the y's. Okay, don't try to grab it all at once. That can get overwhelming, especially when you're just learning this. All right, so now I'm going to do the same thing with each term. I'm just going to look one bit at a time. So 9 divided by 3 is 3. X to the third divided by x squared. 3 minus 2 leaves 1x. And then y squared divided by y squared. There's no more y's left in that term. Minus 3 divided by 3 is 1. Then I have x squared divided by x squared. That's 1. And then y squared divided by y squared is 1. So what's left in this middle term? What do I have to write down? 1. It's the same thing that happened up in exercise 4. What I factored out is the exact same thing as that middle term. So it basically cancels out, but you have to leave the placeholder of 1. And then the last term, I've got 6 divided by 3 is plus 2. X squared divided by x squared, I've taken out all of the x's, both of them. And then y third divided by y squared, I started with 3 y's, I factored 2 of them out, so I'm left with 1 y. And there's my result. All right, I've got one more of these. So exercise 9, go for it. All right, so looking at the coefficients, I've got 25, 15, 20. What can I factor out of all of those? 5. Yep. How many a's can I factor out? 4, because I got a to the 4th, a to the 5th, a to the 4th. So the lowest power is a to the 4th. And then how many b's can I factor out? Yep, lowest power of b is b to the 3rd, right there in that first term. 25 divided by 5 leaves me 5. A to the 4th, I took out 4 a's, so there's no more a's in the first term. And then there's no more b's in the first term, because I started with b to the 3rd, I factored out b to the 3rd. So the only thing left in that first term is 5. And then plus 15 divided by 5 is 3. A to the 5th divided by a to the 4th, I started with 5, I took 4 of them out, so that leaves me 1. And then b to the 6th divided by b to the 3rd, I started with 6, I took 3 out, that leaves me 3. Minus 20 divided by 5 is 4. Started with 4 a's, took out 4 a's, so there's no more a's left in that term. And then b to the 6th, took out 3 b's, b to the 3rd, so that leaves me b to the 3rd. All right, so hopefully there's a whole bunch of MyMathLab problems. You're going to practice that. I'm hoping that you get nice and good and feel super comfortable factoring out a common factor. There's going to be several problems on the next test, just like these ones right here, so that you get your confidence going right at the beginning. And so we're going to continue talking about taking out common factor, but what I'm working toward is when we come back next week and we factor things that are slightly more complicated, okay, I want to build up to teaching you a process to do that that'll work every time, no matter what. Okay, that is my goal. So a couple things that'll be helpful for us. Example 4 right here, I've got this thing right here. It says negative x squared plus 5x minus 14. The thing that I just want to point out to you about this is something that will make factoring easier. Okay, I mean, I know it's a hard thing, but something will make it easier is if the coefficient in front of that first term, if that's positive. It just makes life a little bit easier, less complicated. And so all that means to do, hopefully not anything too challenging, but when I notice I've got a negative in front of that first term, I'm going to factor out a negative. So I'm going to put a negative and I'm going to write some parentheses right here. And then when I factor it out, a negative x squared divided by a negative, what does that leave me as my first term? A positive x squared. And then a positive 5x divided by a negative leaves me what? Negative 5x. And then finally, negative 14 divided by a negative leaves me plus 14. So hopefully not anything that's too, too terrible, but it's something that will be part of a bigger problem later. So exercise 10, same thing. I'm going to give you 20 seconds. Factor out that negative of that trinomial, that expression with 3 terms. All right, so I'm factoring out the negative, and here's my parentheses. And when I factor out the negative, tell me what's the first term? Positive y squared. What's the second term? Positive 7x. And what's the third term? Beautiful. Wonderful job. All right, last problem on the front page. Exercise 11 just combines both the things. The first term's negative, and in addition, there is a factor in common to all 3 terms. So do both of those things, please. All right, so in addition to the negative, what is the factor that I can take out of every term? A 2. So I'm going to factor out a negative 2 out of the 3 terms. So when I do that, negative 2 divided by negative 2 is a positive 1. That just leaves me x squared. A 4 divided by negative 2 is negative 2x. And then a 16 divided by negative 2 is negative 8. And I look at those 3 terms. There's nothing in common to all 3. So we are done with that problem. All right, before I flip the page, we doing okay with factoring out a common factor? All right, so now we're just going to kind of continue with that skill. So we're not abandoning it, but we're going to use it in different formats. So example 5 is my example. This is going to be a factoring out the common factor problem, but my terms look a little different. I have 2 terms. Remember, terms are when I have things multiplied together. So what I have here is I have this first term, okay, that I'm underlining, x minus 5 times x plus 6. Because those 2 things are multiplied together, that is 1 term. They go together. And then plus, and then I've got x minus 5 times 2x plus 5. That's my second term. Now, the reason for this problem that we're doing is this problem represents a step in what we're going to do next. Okay, so there is a purpose for the next couple problems. So looking at these 2 terms, I've got x minus 5 times x plus 6 is term 1. I've got x minus 5 times 2x plus 5 is term 2. Is there something there that you see that both of those 2 terms share that's exactly the same? Yeah, the x minus 5. Yeah, so what I'm going to do is I'm going to factor that out. Okay, so I'm going to factor out the x minus 5. And then I'm going to use another set of parentheses, and I'm just going to draw them a little bigger so that you know where I am. So I'm just drawing a little bit of a bigger parenthesis. The x minus 5 is the thing that I factored out both of those terms. Use your thumb if you need to, but when I look at the first term, when I factor out the x minus 5, what's left? Yeah, when I cover up the x minus 5, what's left is the x plus 6. Did everybody see that? Okay, so I'm going to write that down. X plus 6 is left right here. Then I've got this plus. I'm going to just carry that down. I'm going to put a plus right there. And then the second term, the x minus 5 times 2x plus 5. When I factor out the x minus 5, what's left there? I cover it up, 2x plus 5. Fantastic. And so I'm just going to write that right there. And so I got one more step, and then this will be nice and cute and all taken care of. The x minus 5 I factored out. Now looking in that parentheses, when we wrote down what was left from each of the two terms, you notice that there's some like terms there. And so I'm just going to go ahead and I'm going to combine those like terms. So I've got x plus 2x, that's 3 of them, 3 x's. And then 6 plus 5 is 11. And there we go. There is my factored, simplified expression that I started with. And that came from, I see that there's an x minus 5 in both of those terms, so I factored it out. So exercise 12 is an identical problem in steps, just a little bit different in numbers. So give it a try, see how you do. So looking at exercise 12, here's my first term. I've got 3x minus 2 times x plus 1, term 1. And then my second term is 2x minus 5 times 3x minus 2. So looking at those two terms that I've just drawn the bracket over the top of, what factor is in common to both? Yeah, there's a 3x minus 2 right here and a 3x minus 2 right there. That's what they share. So I'm going to factor it out. So 3x minus 2. And then here's my parentheses. We're going to represent what's left over. So when looking at the first term, when I factor out the 3x minus 2, what's left from that term? Yep, x plus 1. And then that plus sign, I'm just going to drop it down, plus. And then from the second term, when I factor out the 3x minus 2, what's left over? Yep, 2x minus 5. That's all that's there. And last step, I can clean up that second factor a little bit. And so we'll do that. X plus 2x is 3x. 1 minus 5 is negative 4. And there's my factored and cleaned up expression. So far, so good? All right, exercise 13. Very similar problem. Okay, so go ahead and give that a try. There's two terms there. They have a common factor. In fact, there's going to be one less step on that one. There's nothing to clean up at the end of this one. So looking at these two terms, I've got z squared times m plus n, and then I've got minus 10, m plus n. What's in common to those? M plus n, right? And then when I factor, what's left from the first term? Z squared. I'm going to bring that minus sign right down, and then what's left from the second term? 10. Perfect. There you go. Done. Excellent work. All just factoring out the common factor. And so that leads us to the next problem. As we go through this unit, we're going to develop a few ways to factor things, to write things in a more usable form. This is going to help us out when we get to Unit 4 in this class, Unit D, and we talk about things that I need to simplify. Being able to factor is going to be super useful. And like I said, when you get to college algebra, if pre-calculus is your math destiny, the ability to factor is going to be assumed in that. So in example 6, here's what I've got. I've got this thing right here, and I've got 4 terms. I've got ax, ay, bx, and by. And here's what I notice. When I ask myself the question, is there something in common to all 4 terms? There's not. There's not one thing that I can draw out of all 4 terms. So before I give up, though, I want to know, is there a way that I could write this simpler? Can I factor this? And so what we're going to do is we're going to develop a process for when you have something that has 4 terms. Okay, so the process we're going to do now applies when you have an expression with 4 terms. And what we're going to do is something called grouping. And here's what grouping needs to do. Again, you may have seen this before. Factoring is super common in high school algebra classes, so you might know exactly what's going on. All grouping means is this. In order to write this thing with 4 terms as a product, okay, that's what factoring is. In order to write this as a product, what I'm going to do is I'm not going to look at all 4 terms. I'm going to look at the first 2, and I'm going to look at the last 2. So now, forget that the last 2 are right there. Looking at the first 2 terms, ax minus ay. Is there anything in common to those 2 terms? Yeah, an a. So I'm going to factor out an a. This is the grouping step. This is why it's called factoring by grouping. Instead of looking at all 4 terms, I'm looking at pairs. I'm looking at the first 2, then I'm going to look at the second 2. And when I factor the a out of the first 2 terms, ax divided by a leaves me x. And then negative ay divided by a leaves me negative y. That's just what we were doing on the front page. Absolutely no different. The only thing is I just looked at the first 2 terms. Now, forget the first 2 terms are there. Let's look at the second pair of terms, bx minus by. What do those have in common? Okay, so I'm going to write a plus b right here. You might be saying, hey, Perkster, why did you write a plus? I'll answer that question in just a problem or 2, so just trust me for the moment. Okay, plus. And then when I factor out the b, bx divided by b leaves me x. And then negative by divided by b leaves me negative y. I'm going to give you a minute to write that down, and then we've got one more step. We're just doing common factors, but we're doing it twice. So now this problem, I've looked at the first 2 terms, I've looked at the last 2 terms, that's the grouping step, I get this, and now this becomes the problem, exercise 13. In these 2 terms, do you see something that they share in common? Yeah, an x minus y. So here we go. This is going to be the final result then. I'm going to factor that x minus y out of both terms. And when I factor the x minus y out of the first term, what's left right here when I factor the x minus y out? A. And then what's left here when I factor the x minus y out? Plus b. There you go. And if you remember, because this is knowledge that we assume you come in with, if you remember foiling from algebra, first, outers, inners, lasts, if you multiply these 2 things together, you get those terms right there. If you don't remember foiling, let me know. I got a video I can share with you. I can give you the link, and you can do a real quick review on multiplying 2 binomials together, okay, so that you can check your answers here. So I'm going to leave that right there. Exercise 14 is super similar. Okay, it looks almost like the identical problem. So factor exercise 14 by grouping. Look at the first pair of terms, take out what's in common. The second pair of terms, take out what's in common, and then finish the problem. Just to give everyone a nudge, what you're doing, hopefully, is you're grouping. You're looking at the first two terms and you're saying what's in common to those two only. And then you're looking at the last two terms and saying what's in common to those two only. And then you're factoring. So I'm going to give you another 30 seconds. Make as much progress as you can. And if you make any mistakes, you see that we've got several more examples. So you're going to get your chance to work this out. So looking at the first two terms only, what do they have in common? A 3? Okay, great. So that we'll start there. So 3. And when I factor out the 3, now this is just what we were doing on the front page. 3m divided by 3 leaves me m. Negative 3n divided by 3 leaves me negative n. And now looking at the last pair of terms, what do those two have in common? X. I'm going to write a plus X. Again, when we get to example 7 in a minute, I'll explain how you know if that's going to be a plus or a minus. Okay, but for right now, just trust me. And so I'm going to factor out a plus X, and then xm divided by X leaves m. A negative xn divided by X leaves negative n. And there we go. And I know the grouping works when I've got the exact same thing in parentheses, so I can factor. And so my second step is this m minus n that both of these have. I'm going to factor it out. M minus n. And here we go. When I factor the m minus n out of the first term, what's left? 3, and then plus x. And there we go. There's my factored expression. Do exercise 15. Again, very similar problem. I'm just changing the letters and the numbers just a little bit. All right, so let's get started. If you have a question, if there's any way you need to respond to this, please let me know. So I've got 2ax plus 4bx plus 3ay plus 6by. So looking at the first two terms, what do 2ax and 4bx, what do they have in common? They have an x. They also have something else in common. A 2, yes. 2 and 4 both share a 2. So a 2 and an x. So if you didn't see the 2, that's okay. Forgive yourself. You'll get another shot. Hey, don't worry. You're learning. So 2ax, when I factor out the 2 and the x, I'm just left with a. 4bx, when I factor out the 2 from the 4 divided by 2 leaves me 2. And then when I factor out the x from the bx, that leaves me b. So I have a plus 2b. And then when I look at the second pair of terms, I've got 3ay and 6by. What do those two terms have in common? A 3 and a y, okay? The common factor between the 3 and the 6 is a 3, and then you can see the y sitting there for both of those. So I'm going to put a plus, a 3, and a y. So 3ay, I factored out the 3 and the y, that leaves me a. 6 divided by 3 is 2, and then by, when I factor out the y, leaves me b. And so here's the question. Observing what I have now, did the grouping work? Am I able to go further with this? How do you know the grouping worked? Exact same thing in parentheses. Yeah. If you have anything different, then maybe you made an arithmetic mistake, or maybe but it should work out. Everything I give you on the next test will be factorable. You will be able to factor it. Okay, I'm not playing any tricks or gimmicks on you. So you learn to factor, you're going to be able to work the test. So the a plus the 2b, that's what they have in common. And then when I factor out the a plus the 2b, there's a 2x left from the first term, and then a plus 3y left from the second term. And there we go. That's my answer. All right, I've got one more example, and then you've got a few more that you're going to do as we approach the finish line here. So example 7, the reason for this example is this. On all the grouping problems, I've assumed a plus between the two terms, and you might be thinking, how do you know? Like, how would I know when it's not going to be a plus? Well, this is my example to show you how we'll know. So again, I'm going to group. I'm going to look at the first two terms. I'm going to look at the second two terms. So from the first two terms, 3x minus 3y, I can take a 3. 3x divided by 3 leaves x. Negative 3y divided by 3 leaves negative y. I'm going to pause there and let you catch up, because now we've got to observe something, and this is kind of the key. And again, the more you do of these, the better you get. Math is like anything, like a video game or a sport or art or music. The more you do it, the more proficient at it you will get. Okay. So now I'm done with my first two terms. Let's look at the last two terms. What's the sign on my x term? A negative. What was the sign on my original x term here in the parenthesis? Positive. Notice they're opposites. What's the sign on my last y term here? What's the sign on the y term in the parentheses? Negative. Can everyone see that those are opposite signs? Okay. I'm just going to make a little note for you, because I know our short-term memory leaks away from us. These two terms here have opposite signs of what's in the parentheses. That is your clue. When they have the opposite signs, that you're going to factor out a negative. And if you look back up at example 6 and exercises 14 and 15, you'll notice that they all have the same signs. Okay, when you pair them up. That's why I said not to worry about it. So when they have the opposite signs, I'm going to factor out a negative now. And then ax and ay both share an a. So I'm factoring out a negative a from both of those terms. Again, if you're writing it down, you're like, why am I taking out a negative? I'm factoring out a negative because these two terms here, the x term and the y term, have the opposite sign of the x term and the y term in parentheses. Everything has to be the same. So when I do that, a negative ax, I factor out the negative a. I'm left with a negative divided by a negative leaves a positive x. And then the positive ay divided by negative a positive divided by a negative is a negative y. And then again, the clue to me that I did this right and I got my signs right is because I have the exact same thing in parentheses, which I can now factor out. And then when I do that, I've got a 3 left from the first term and then a negative a left from the second term. And there we go. Exercise 16, right next door, is the exact same process. Okay, so make sure that you can identify why you're factoring a negative out of the next problem. All right, so I'm going to get started. If you're working, keep working. We'll check up, but here's my grouping step. I'm grouping the first two and the last two. Out of the first two terms, I've got AB and negative 7a. Hopefully we can see they both have an a in common. And when I factor that out, AB, when I factor out the a, leaves b. Negative 7a, when I factor out the a, leaves negative 7. Now here's the key to this problem. My first term is a negative 5b. The b in the parentheses is positive. Can you tell that those have opposite signs? Are you tracking with me on that? And then my 35, my number is positive, and then the 7 here in the parentheses is negative. Opposite signs, right? So that's my clue that I'm going to factor out a negative something. And it's a negative what from those two? 5. Yep. Okay. And then negative 5b, a negative divided by a negative leaves me a positive b. Positive 35 divided by negative 5 leaves me negative 7. And once again, my grouping worked. I've got a b minus a 7 in both parentheses, so I'll factor it out. That's my common factor. That's what this whole section's been about. And then I have an a left from the first term and a minus 5 left from the second term. And there's my factored expression. To stay on theme, we're going to go out of order the next couple of problems. Do exercise 18 right below. It's another one where you have to worry about the sign. Right, so my grouping, first two terms, last two terms. My first two terms, I've got m to the third plus 4m squared. This problem is just a reminder that you always take out the lowest power. So I'm going to take out an m squared from both of those. So the first term, I started off with m to the third. I took out m squared, so 3 m's. I took out 2, that leaves me 1m. Then plus 4m squared, and I took out the m squared, that leaves me plus 4. Once again, my next term is a minus 6m. In parentheses, I have a positive m. Then I have a minus 24, and in parentheses, I have a positive 4. So again, opposite signs. Make note to yourself if you didn't quite see that. These two terms here have the opposite signs of what's in parentheses. So I'm going to factor out a negative. And from those two terms, 6m and 24, I can take out a 6. A negative 6m divided by a negative 6 is a positive m. A negative 24 divided by a negative 6 is positive 4. And my grouping worked. I've got the m plus 4 in common, so I'll factor it out. That's my common factor. And then m squared minus 6 is what's left over. All right, just a couple more problems. We're almost done. I appreciate it. You guys done great today. Exercise 17 is just a standard grouping problem. So go ahead and do exercise 17, please. So my grouping, I've got 6ax plus 12bx. 6 and 12 share a 6. A and B are different, but they both have an x. So 6ax, when I take out the 6 and the x, leaves me a. 12 divided by 6 is plus 2. And then bx, when I take out the x, leaves me b. So a plus 2b. The signs are the same, so I'm just going to put a plus right here. But then, can I take anything out of these two things right here? No. But what do I notice about these two things in the parentheses? They're the same. So what I'm going to do is I'm just going to rewrite this. I'm going to put some parentheses around the a plus 2b, okay, because they're the same thing as what I already had. And so now my grouping did work because I've got a plus 2b and a plus 2b. And what's left from the first term is the 6x. And then what's left from the second term, since I factored out, we saw this on the front page, so this is a review. I factored out exactly what's there. It was an a plus 2b. I factored out the a plus 2b. So what do I have to write right here? A 1. Yes, well said. Perfect. All right, exercise 19. We're almost done. Great job. Lots of problems because I wanted to get in lots of practice because this is the only section we're doing today. Exercise 19. My purpose for exercise 19 is this. When I look at the first two terms and the last two terms, I've got p squared, q squared minus 10. Is there anything in common to those? No. The second pair of terms is negative 2q squared plus 5p squared. Is there anything in common to those? Okay. On the occasion that this happens, all you're going to do is you're going to try to do this. I'm going to rearrange the terms. I'm going to take this negative 10 since it doesn't have any variables, and I'm going to move it to the end of the train. So I think there's a problem or two in my math lab that at first glance, it looks like it might not work, but don't fear, move one of the terms to the end, and now I've got p squared q squared minus 2q squared plus 5p squared minus 10. Okay, I've just moved that 10 to the back. So I'm going to give you a minute or so to go ahead and group this. And then while you are doing the last problem, I'll pass back your tests, and then we'll go over that last problem and we'll be done for the day. All right, so when I go ahead and group now, the first two and last two, the first two share a q squared. So p squared q squared, when I factor out the q squared, leaves the p squared. And then negative 2q squared, when I factor out the q squared, leaves negative 2. The second pair of terms, 5p squared and 10, share a 5. 5p squared divided by 5 leaves p squared. And negative 10 divided by 5 is negative 2. My grouping worked. There it is. That's the thing they have in common. What's left from the first term is the q squared. What's left from the second term is plus 5. All right, so the last one, exercise 20. While you're working on this, here's a little hint for you. Before you worry about grouping, notice all 4 terms do have a number in common. There's a coefficient. So first, you're going to factor out the common coefficient to all 4 terms, like we did on the front page. And then you're going to group what's left over like we did on the second page. All right, here we go. The first thing I told you to do is there is a factor in common to all these. What's the number in common to all 4 terms? There's a 4, so I'm going to do that first. I always recommend anything we factor in this whole unit, take out the common factor first because it makes life a little easier. So I've got 3wy minus 6xy plus wz minus 2xz. This 4 is going to be part of my final answer. I'm gonna leave it out for now, but when we get to the end, I'm gonna put that 4 first. And so when I do my grouping here, the first 2 terms, I can take out a 3 and a y. 3wy, when I take out the 3 and the y, leaves w. Negative 6 divided by 3 is negative 2. And xy, when I take out the y, leaves x. And then the second pair of terms, when I factor out what's in common, I can take out a z. And then wz, factor out the z, leaves w. Minus 2xz, take out the z, leaves negative 2x. The grouping worked. I've got w minus 2x on both of those. So I will factor that out. I drew my arrow a little too far down, but that's okay. So I've got w minus 2x. And then what's left from the first term is 3y. And the second term is plus z. There you go. That is common factors. So please